Hey kids, welcome back to some more science, some more space science. Space science is cool. This is our last week to talk about space science. I'm sad too. I love learning about space, but we have other things to talk about in science, so this will be our last video. This week, we are going to focus on what else is out there. We learned that our sun is the center of our solar system. We learned that there are 8 planets in our solar system, 4 rocky planets and 4 gas giants. Well, 2 gas giants, 2 ice giants, same difference. And we also learned that our solar system is part of a larger system called a galaxy, and that our galaxy is one of millions of galaxies in the universe. Universe is everything. Galaxies, solar system, ta-da! But those 8 planets and our sun are not the only things in our solar system. There's more things out there. I'm talking asteroids, comets, meteors, dwarf planets. Let's talk about those things. What are they? Where are they? You're going to learn about these items. Then you are going to make a delicious asteroid cookie. So let's learn about this stuff. Let's get started. Science is cool. Before we dive into what else is out there, we need to talk about some terms, some areas of our solar system. So think about the sun and the 4 rocky planets, Mercury, Venus, Earth, and Mars. Boom, that's the close area to our sun. Then come the outer planets, right? Jupiter, Saturn, Uranus, Neptune. Well, it turns out that in between Mars and Jupiter, there's an area called the Asteroid Belt, and it looks like this. The Asteroid Belt is an area of space filled with little asteroids, rocks, junk kind of left over from Lord knows what. Scientists think perhaps maybe planets that didn't form, maybe stuff that got broken up and just sort of got captured by the sun's gravity. And this whole belt of junk is orbiting around the sun between Mars and Jupiter. Now, in this picture, it looks like it's a lot of stuff, and it kind of is, but most of the stuff is small. If you put all that stuff together, it still wouldn't even be bigger than the Earth's moon. The next area, farther out beyond Neptune, is another area called the Kuiper Belt. The Kuiper Belt is more of a donut shape. The asteroid belt is sort of flat. It's on the same plane, like a disc. Think of a frisbee. Everything's kind of on a disc, a flat plane. Once you get out to the Kuiper Belt, it's a little more donut shaped, like that. And it's also filled with debris, rocks, chunks, ice, whatever, all spread out again. That's the Kuiper Belt, right past Neptune. Keep going beyond that Kuiper Belt, and you get to an area called the Oort cloud. Now, the Oort cloud is not something we've actually seen. Scientists have not seen the Oort cloud, but they've thought about it, and based on computer models and a lot of thinking, they believe there's something out there called the Oort cloud. And the Oort cloud is not a flat area of stuff. It's more of a sphere. So maybe to help you think about this, how about if you think of the solar system as being like a dinner plate, and all the planets in the sun rotate around on their little orbits on that dinner plate. Now, go to your closet and get an inner tube, one of those floaty things that looks like a donut, blow it up, put the dinner plate inside of it. That floaty thing on the outside is the Kuiper Belt, the dinner plate's the solar system. Now take that whole thing and stick it inside of a really huge balloon. That's the Oort cloud. All right, now that you understand those 3 areas, the asteroid belt, the Kuiper Belt, and the Oort cloud, we can talk about what else is out there. And the things we're going to talk about are meteors, comets, asteroids, and dwarf planets. Let's start off with dwarf planets. There's been a lot of news about dwarf planets, mostly because of our little friend Pluto. What is Pluto? Is it a planet or not? Well, as you may have heard, Pluto kind of is a planet. It actually belongs to a special kind of group called dwarf planets. Originally, it was thought to be a planet, but what happened is astronomers found a whole bunch of other objects about Pluto-sized, right beyond Pluto. And they even found one closer up in the asteroid belt. So long story short, because there's a bunch of other objects that are Pluto-sized, astronomers had to come up with a new term of dwarf planet. So let's talk about what is a dwarf planet, and how is it different from a regular planet? First of all, dwarf planets orbit the sun, just like a regular planet. That's the same. Dwarf planets are kind of spherical or roundish in shape. They're not lumpy little potatoes. Well, they're not supposed to be, although some of them look a little lumpy. But the big difference between dwarf planets and regular planets is a regular planet has its own orbit. It doesn't orbit with a bunch of other planets the same size as it is, like Jupiter's by itself. It's got moons, but none of those moons is close to Jupiter size. When you have a dwarf planet, it shares its orbital lane with other things that may be close in size to itself. That's a really big difference. Dwarf planets can have moons, and some of them do. 5 designated dwarf planets, but more are being discovered kind of all the time. There's a process for a planet to be actually officially declared a dwarf planet, so some of those haven't been declared yet. We'll talk about one of those later. But right now, the 5 known dwarf planets are Pluto, Eris, Haumea, Makemake, and Ceres. Of all these 5 dwarf planets, 4 of them are located beyond the orbit of Neptune in that Kuiper Belt area. Only one of them, Ceres, is located in the Asteroid Belt between Mars and Jupiter. Dwarf planet number 1, Pluto, the best known dwarf planet. This little dude orbits beyond Neptune, yep, out in that Kuiper Belt. Now, the crazy thing about Pluto is, unlike the other planets, it doesn't stay on that flat dinner plate plane. It actually kind of goes at an angle. And its orbit isn't really all that round. It's more of an ellipse, like an egg-shaped. There are times that Pluto is actually closer to the sun than Neptune is. So that should have given scientists a little bit of a heads up that maybe there's something weird about Pluto. Turns out there is something weird. It is a dwarf planet. Pluto has 5 moons, the largest one being Charon. Charon is almost as large as Pluto. So sometimes Pluto and Charon are considered like a double planet. They orbit around each other. Pluto's other 4 moons are Nix, Styx, Kerberos, and Hydra. While the moon Charon is pretty spherical shaped, the other 4, not so much. It takes 248 years for Pluto to orbit the sun once. That makes it pretty far, and as you can guess, it makes it pretty cold. Pluto is smaller than Earth's moon. It's a tiny little thing. Another clue that maybe it's not a true planet. Just saying. In 2015, the NASA probe New Horizons did a flyby of Pluto, got some totally excellent picture and all this data that we've learned. Until then, we really didn't know a whole lot about Pluto, because remember, it's really far out there. Next, let's talk about Eris. Eris, like Pluto, is located way beyond Neptune in that Kuiper Belt area. Eris is bigger than Pluto. It has one little moon, Dysnomia, but it is bigger than Pluto. So this sort of sparked the discussion on what's a planet, because first there were 8 planets they could see with telescopes, and then when they got better telescopes, they found Pluto, and then they found Eris. So do we have 8 planets, 9 planets, 10 planets, 100 planets? Scientists realized they were going to be finding lots of other little planetoid things. Are they all planets? They decided that no, we need to have a new class of planets called dwarf planets, and we'll put these little guys inside there. So Eris, being larger than Pluto, is also just a dwarf planet. It is located way out past Neptune, and we have not had any probes there. It's pretty far away. Our next dwarf planet is Haumea, and it also is located out in that Kuiper Belt. Haumea is not quite spherical like the other dwarf planets, but it's spherical enough to still be considered a dwarf planet and not like a lumpy asteroid, despite its weird shape. Haumea has 2 little moons, Hi'iaka and Namaka. You might wonder at some of these odd names. In the past, it was sort of traditional to name the planets after Greek gods, but some of the newer ones are named after other folklores. This planet is named after Hawaiian gods, hence the Hawaiian-y sounding names. Our next dwarf planet is Makemake, and not a whole lot's known about this other than it has no moons. The last of our 5 officially recognized dwarf planets is Ceres. This little guy is located in the asteroid belt, just beyond Mars. It is the closest dwarf planet to us, and it is the smallest of the 5 dwarf planets. This little dwarf planet takes 4.5 years to orbit our sun. It has no moons. From 2011 until 2018, the Dawn spacecraft visited this planet, did some flybys. Here's a little video to show you what they found.
This is Ceres, the dwarf planet that Dawn's been orbiting for more than a year now, providing us with fascinating views of an alien world. During its exploration, Dawn has moved closer and closer, allowing us to get a broad overview and then see exquisite detail. This is Haumea, the highest mountain on Ceres. Towering in an otherwise unremarkable area, it seems very odd that it rises so sharply, and geologists still don't know why. On its steepest side, it soars 3 miles, higher than any peak in the continental United States. Haumea crater, one of the brightest regions on Ceres. You can see a substantial amount of bright material, which the latest analyses indicate may be a kind of salt. Dawn is now orbiting only 240 miles above Ceres, which is closer than the space station is to Earth, and it will continue to return spectacular views.
Okay, you remember how I said that there may be more dwarf planets out there? Well, this next thing, Sedna, is probably going to be our next dwarf planet. It's pretty much guaranteed. It fits all the descriptions. The reason it hasn't is we just don't know a whole lot about it yet, other than the fact it is really far away, located in the Oort cloud. The orbit of this little dude is not circular like the rest of the planets and dwarf planets, but it's more oval, pretty long oval. The orbit looks like this. This guy is so far away that it's almost like a comet, except that it's not. It's because of what it's made up of, it's considered a planet, or a dwarf planet. It takes about 11,000 years for this little dwarf planet to go around the sun one time. Here's a picture that an artist drew about what the sun might look like if you were standing on Sedna. It would be super tiny. So those are our 5, possibly 6 dwarf planets. Let's talk about the next what's out there topic, asteroids. Asteroids are almost like dwarf planets, but not. They tend to be smaller and not necessarily round. They can be any shape, kind of lumpy, bumpy, but they're mostly made out of rocks or metals. That they do have in common with planets. Most asteroids are located in the Asteroid Belt, good name for it, right? Between Mars and Jupiter. That's where the asteroids are. There are asteroids other places, but in our solar system, that's where most of our asteroids are located. Scientists aren't exactly sure where these asteroids came from, but they think they might be leftovers from planets that didn't quite get formed, or maybe if something broke apart or was smashed, kind of ended up in that little belt. I'm not sure whose job it was to count these things, but somehow somebody came up with the count of over 1 million currently known asteroids in that asteroid belt. That must have been a fun job. Now, it looks like there's a lot of material here in this belt, but it turns out that if you lumped all this stuff together, as we mentioned, it wouldn't be any larger than the moon. Most of this material is pretty small. But there are some big ones, and they're interesting. So let's discuss some of the coolest asteroids that we have studied so far. Let's start off with Eros. This asteroid is the closest asteroid to us. Kind of a lumpy potato-looking thing asteroid, clearly not a planet, but it's a pretty cool asteroid. Just so happens, because it's so close, it was the first asteroid that we sent a probe and a lander to. Our second asteroid is Ida, another sort of lumpy looking asteroid that's located between Mars and Jupiter. This little asteroid was photographed by the Galileo space mission on its way to Jupiter. It found this little asteroid and looked at it a little closer. It also found it had its own little moon. Dactyl, isn't it cute? It's cute. Our next asteroid is Vesta. This is an asteroid that was visited at the same time we visited Ceres using the Dawn spacecraft. This asteroid almost looks like a dwarf planet, doesn't it? It's spherical. It almost was a dwarf planet, but I guess it's just not quite big enough. That's Vesta. Our next asteroid is a cool one. Psyche. Kind of looks like the Death Star, doesn't it? All those craters and weird things on it. Turns out this asteroid is mostly made of metals, kind of like the inside of a planet. Astronomers wonder if maybe somehow a planet didn't stay together, and this is the result, the inside part. Doesn't it look like the Death Star? Psyche is so interesting that NASA is sending a probe there. Next year, NASA will launch the Psyche mission, which is a mission to visit this asteroid. After a gravity assist around Mars, it will head out there and be there in about 4 years. This mission will not land on Psyche, it will just do flybys. Here's a quick video to show you what that Psyche mission might look like. Asteroid we're going to talk about is really bizarre. I mean, Psyche was bizarre, but this one's really bizarre. Look at it. It looks like a squashed snowman. This one is called Eris, and scientists think that perhaps it used to be two bodies that somehow got squashed together, like if you take two clay balls and stick them together. I'm not sure how that would happen, but it makes sense to astronomers, and they think that's what happened with this guy. I should mention that this goofy little asteroid is not located close up in the asteroid belt like the rest of the asteroids, but rather way out in the Kuiper belt. It is even farther than Pluto. These awesome images were taken using the New Horizons spacecraft that was sent to take pictures of Pluto and this thing. Those are some awesome pictures. This little asteroid marks the farthest flyby by any probe. That's nice. Okay, so we've talked about dwarf planets, which are like planets, spherical in shape but smaller. And we've talked about asteroids, which don't necessarily need to be spherical in shape, often aren't, and are even smaller still. The next thing we're going to talk about is meteoroids. Meteoroids is a category of objects that aren't necessarily staying in their space. So planets and dwarf planets and asteroids mostly just orbit around in the sun, but they stay in place. Meteoroids tend to leave their orbit for one reason or another. Sometimes it's because they get knocked out of place. So what happens to those objects that go flying off around space? A couple things. So if that chunk of rock ends up in the atmosphere of a planet, it is no longer called a meteoroid, it is called a meteor. A meteor is burned up on entry of that atmosphere. The friction from coming into that atmosphere causes that rock to burn up. Now keep in mind, most of these meteors are pretty small. They're not like house-sized rocks. They might be something the size of my fist or even smaller. They leave a bright trail when they come through. Looking at the heat, remember things get hot, tend to glow, like say a sun or something. We see those and we call those shooting stars. But all it really is a meteoroid that's being burned up in our atmosphere, a meteor. If that meteor, which is coming through that atmosphere, happens to make it to the ground without being completely burned up, it is now called a meteorite. And those guys can leave huge craters, like this one here, or tiny craters. On our planet, a lot of those craters get filled in. We've probably been hit by a lot of meteorites in the past. We just wouldn't know it. But we see a lot of the evidence of this stuff on other planets, don't we, like our moon. Last thing I want to talk about are comets. Comets are, the best way to think of them as big dirty snowballs. They can be larger, and they have the rock and metals and stuff that the asteroids do, but they also have ice and snow chunked onto them as well. Frozen ball, like a really frozen ball. They're located way out in the Oort cloud. They have a really long orbit. It takes them a really long time to come in towards our sun where we can see them. But as they approach our sun, the heat from our sun starts to melt that chunky ice ball, and the snow and ice kind of comes off the back of it in what looks like a tail. So comets look like they have tails streaking through the sky. And when we can see comets, we can see them for a long period of time, but then once they get around our sun and they zip back out and freeze up again, we don't see them anymore for a very long time. The most famous comet is Halley's Comet, which is also called a short period comet because it's a comet that we actually can see in our own lifetime. This comet was last seen in 1986. I look like that. Still cute. This comet will be visible again in 2061. That's 40 years from now. You'll be around to see it. How old will you be? Another famous comet is the Shoemaker-Levy 9 comet. This comet is famous because as it passed a little too close to Jupiter on its way through our solar system, it got ripped apart into little pieces, and those pieces crashed into Jupiter.
The Hubble Space Telescope took these images.
So that's what's out there. Dwarf planets, meteors, asteroids, comets. Those are the other things in our solar system, located in the Asteroid Belt, the Kuiper Belt, and the Oort cloud. It's been a lot of fun exploring outer space with you. There's a lot of great books at the library. There's a lot of great videos on YouTube with parental permission that you can watch. So don't let this be the end of your exploration of space. Go at it, have fun, learn lots, and remember, science is cool.
Cooking project time! Here's the recipe for your asteroid cookies. Take a screenshot and print it out.
Here's what you're gonna need to make your asteroid cookies. Flour, vanilla, softened butter, not melted, but softened, 1 stick, a cup of mini chocolate chips, and powdered sugar. Alrighty, let's get started. So, first thing we're gonna do, wash your hands, which I already did that. Next, I'm gonna add my softened butter into my bowl. Okay, there it is, just a stick of butter. Now I'm gonna beat this until it's all soft and mushy with an electric mixer. Okay, that's pretty soft. Next, I'm gonna add a 1/4 cup, the 1 and the 4, powdered sugar. Plop. I like powdered sugar. And 1/2 teaspoon of vanilla. I didn't bring a half a teaspoon, but I know that my cap is a full teaspoon, so I'm just gonna add about 1/2 cup. It's okay if you add too much. Vanilla's yummy. I'm gonna mix that up. Yep, there we have it. Okay, now I'm gonna add my flour. I'm gonna add 1 cup and a little bit more of flour. 1 cup and a little bit more of flour. Okay, I mixed this up, but it looks pretty powdery. You know you're done when you can take a handful of it and kind of squeeze it together and it stays. This is a pretty buttery dough, so it's not gonna hold together great, but that's what's gonna make it taste good. So when your dough is all mixed up, but you can squeeze it into a ball, it's ready for the chocolate chips. All right, next is to add our cup of chocolate chips. That's about a cup. I'm not gonna dump them all in. And mix them up. Doesn't take much to mix those up. Now we're ready to make some cookies. Okay, for this final part, you're gonna scoop out some dough with your clean hands and just squeeze it. Squeeze it into a ball. Squeeze, squeeze. About a ping pong sized ball. We're gonna do that till all the dough is gone. Okay, there they are. I got 14 cookies out of this recipe, and they are a little bit crumbly and kind of falling apart a little bit, but don't worry about that. That's just the butter because it's very crumbly. It is a crumbly cookie. It's supposed to be a crumbly cookie. They're very yummy. We're gonna put these in the oven at 375 for about 15 to 18 minutes. Then we're gonna see what we get. Let's do it. Okay, our asteroid cookies are done. A little bit brown on the bottom there and on the sides. Now remember, asteroids are made up of like rocks and snow and ice. So that's what the chocolate chips are. But I can also kind of jazz this up a little bit with some snow, powdered sugar. And I'm going to use a sieve to sprinkle it on. But if you don't have one of these, sprinkle, 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 sprinkle. You can just roll them in powdered sugar too. Make sure you let them cool first, otherwise they're going to melt the powdered sugar and make kind of a big mess. There we go. It's got snow, it's got ice, it's got chunks of rocks. It's my asteroid cookie. Let's find out how they taste. Oh, they're very buttery. These are really good.